we're going to add some new ideas, which include decimals and fractions. Don't look so happy. Yay. Okay? It's actually not too bad. Okay? I think, for the most part, I'm going to deal with it as fractions. And here's the strategy. Yes, it is more difficult with fractions. So what we're going to do is we are going to factor out the fraction. You can put the word decimal in there as well, but it's going to be, I think, easier to see things as fractions. So the first one, I'm going to change minus 1.5 to 3 over 2, and I'm going to change 0.5 to 1/2. And I have a fraction because there is a 2 on the bottom with my denominator. So because I don't want to deal with that fraction, I'm going to factor it out. You're going to factor it out of all 3 of those. I'm going to put the arrows there already because if you think of the arrows there, your mental math will be easier. If you think of, how do I factor a half? There's no half in the first one, I'm stuck. It's not so bad, okay? How do you factor a half out of 1? Well, if you think of the arrows, what would have to be here to get an x squared? Would you agree there would have to be an x squared there? But if it was just an x squared, what's a half times x squared? 1/2 x squared. There has to be a number in front. What number could be in front? If I multiply it by a half, I get, right, there's an invisible 1 here to begin with. That's what I need. What number would have to be in the front? So when I multiply by a half, I get 1. Can you see it? 2. Excellent. Right? Because 2 times a half is 1. So when we're factoring a half out of 1, okay, this is brain-wise, factoring something out is like dividing. How many halves fit into 1? How many 500 ml bottles in a 1 liter bottle? If I say it that way, you like right away you can visualize there's 2, right? That's what's happening when we're factoring out a fraction. So now, what would have to be here? See a minus sign, it would probably also still have to be a minus sign. A half times what would give me 3 halves? Again, we have to think about how do we multiply fractions? You multiply the top, you multiply the bottom. Does it make sense? Right? 1/2 times something here, question mark, has to equal 3 over 2. Right? Because then I distribute that, whatever's there, 1/2 times that would have to equal 3 over 2. How do you multiply fractions? You multiply the tops, you multiply the bottoms. Is it pretty easy to see that this question mark on the bottom has to be a 1? Because 2 times 1 would be 2. What does the question mark at the top have to be? 1 times something is... And so this number has to be a 3x. And then the last one, I think you're going to get this one. 1/2 times what is 1/2? I think you're going to see right away that it's going to be a +1. So if you have a fraction or a decimal and it says factor, the first thing, the main new step, new from grade 10, because you've not seen these before, is factor out that fraction as a common factor. Then keep that common factor out, and the rest we're going to see if we can factor like normal. My first ones and my last ones. This is actually technically the easiest one in the world to factor. Why? If your first one's a 2x squared, do you see you only have one option? It has to be 2x and x. If your last one is a 1, you only have one option. 1 and 1. I have so far not had to do any thinking because I had only one option. Wouldn't life be good if you didn't have to think the rest of our lives? Everything would be maybe boring. Maybe life would be boring. We do have to think a little bit. What are the signs? Are they both plus signs or are they both minus signs? because we need the outside and inside to give us minus 3x. I need a minus 2x and a minus 1x to give me minus 3x. Quickly in my head, double check it. And so now we have factored this. So the new strategy is, what do we do if we have a fraction or a decimal? I think it's easier to work with fractions, but you could have also taken a 0.5 out and done that same kind of thinking. So in our second one, do you see the fraction that we have is a 3 on the bottom? So we are going to factor out a 1/3, and we're going to think about this. 1/3 times what? Right, there's an invisible 1 out there in front. 1/3 times what would give me 1x squared? Well, for sure I need the x squared, right? Can you see that 1/3 times 3 would give you 1x squared? If you take the 1/3 out of the 17 over 3, you're just going to be left with the minus 17. Now I'll show the work for the last one here. You want 1/3 times something to equal 2. It's negative 2, but that negative sign is just going to stay. What are you going to get? Well, are you okay if I change the 2 to 6 over 3? Does that help you see that I could put a 1 here? And does it help you see that what number has to go on the top? 6. So this is going to be minus 6. And then double check, is 1/3 times 6 a 2? Yes. Not sure why the smartboard was mad at me at that moment. But now, got the 1/3 out, now we're going to check, and this one's a little bit harder factoring. But the first one, the 3x squared, really only has one option. It has to be 3x and x, so the start of this one is easy. But the 6 is a little bit harder, because it could be 6 and 1 or 1 and 6, 2 and 3 or 3 and 2. You have 4 mental math things to quickly throw in and check. And as you're checking when you throw one in, you want to check the outside and the inside to get close to 17, adding or subtracting. The 2 and the 3 doesn't work, does it? 6 and 1 is only going to work if the 6 is here, making the outside 18 and the inside 1. Because 18 and 1 subtract to 17. Now if I want negative 17, you see that you would have to have the negative 18 and the plus 1. And now we have factored this completely. So 9, 10, 11, and 18 for practice. I'll give you some time to try some right now.